Let's take a look at another practice problem, but again, the template is totally the same. We're going to start off with some amount of A in some kind of form. Somehow, some way, we're going to come up with moles of A, which we're then going to use our stoichiometric coefficients to get to moles of B. And then somehow, some way, we're going to convert this moles of B into some question mark of B, which depends on the question. So in this case, we're going to take a look at burning ethanol. So ethanol is kind of the alcohol that you drink. It's CH3CH2OH. We're going to burn it, so that means that we're going to combine it with oxygen, and we'll light it on fire. It's going to release a lot of heat. We're going to produce 2 CO2s and 3 H2Os. So let's see what our question asks. It says, how many grams of carbon dioxide are formed when 10.8 milliliters of ethanol, which is the CH3CH2OH, are burned? And then it tells us the density of ethanol is 0.789 grams per milliliter. So again, word problems, they're always tricky. I would always recommend starting off with think about what you want. And this one asks for grams of carbon dioxide. So our want here is grams of CO2. Then we're going to take a look at our units and try to start with the thing that's not a conversion unit. We have, we're given the density, that's a conversion unit between grams and moles. We have our chemical equation, that's a conversion unit between moles of one thing to moles of another thing. And then finally, we have 10.8 milliliters of ethanol. That's not a conversion unit, it's only one unit. So 10.8 ml of our CH3CH2OH. And then we think about what we have here, right? We have milliliters. We can't go straight to moles from milliliters. Think about what else we have. Well, we're given the density of the ethanol, right? It is referring to the ethanol, so we can use it here. Since milliliters is on the top, I want milliliters on the bottom, so 0.789 grams. Remember that the unit always goes with the top number when it's written out like this, per 1 ml. ml and ml cancel out. Now I'm at grams of my ethanol. Well, how do I get to moles? Well, I can just use my molar mass, right? This is something that should be very comfortable with. According to Google, the molar mass of ethanol is 46.07 grams per mole. Grams and grams go ahead, cancel out. Now I'm at moles of ethanol, right? We've reached kind of our checkpoint where we want to get to. As soon as we get to moles of A, that will then allow us to get to moles of B. And according to my chemical equation, for every 1 ethanol, I get 2 CO2. So why am I going to CO2? Because that's what the question asks for. So 1 CH3 CH2OH gives us 2 CO2. Cancel those out, and then I'm left with moles of CO2. Is that what I want? Well, no, actually what I want is grams of CO2. How do I do gram to mole conversions? Molar mass, right? Since my mole's on the top, moles got to go on the bottom, and according to Google, the molar mass of carbon dioxide is 44.01 grams per mole. And then moles and moles go ahead, cancel out. Now I'm at grams of carbon dioxide, which is exactly what I wanted. So now I can go ahead and plug this all into my calculator, and then I get 16.3 grams of carbon dioxide. Again, that might have looked easy because I did it. The question is, can you do it without, any kind of external assistance? And of course, the only way to find that out is through practice.